So here we're going to take a look at, we're going to introduce section 1.4, which deals with proof writing, and in particular a few different proof strategies, right, that we'll go over. But before we go into any one of these, before we go directly into these strategies, right, again, what is a proof, right, is just kind of logical argument, right, to justify a statement, right? So at each step of the way, we need to justify why we make the statement through definitions or assumptions in order to lead to our conclusion, right? We saw the very kind of abstract logical foundation in the deductions, right? Where P, the very basic P implies Q, P therefore Q, right? So just kind of those are like kind of the seeds of proof here, right? Now the different ways that you can prove something, right? And it's going to be valid too, you know, in justifications, definitions, right? Our domain of discourse, what that we define, so we know what where we're working at. So here's an example here, and again, for now we won't go directly into the proof, but just to get an idea of the type of questions we'll be asking, right? If AB is an even number, then A or B is even. Okay, now one thing that's not considered a valid proof is, let's say if you said, all right, what if AB is 12, right? And I can write 12 as 4 times 3, right? And now I have, all right, well, 4 times 3, one of those is even, right? I'm done, right? This is not a valid proof, right? This is an example of my implication here where it is true, okay? But it does not constitute a proof, right? Here in this case, we call this A, B. You got A is even. All right, this form of argument, right, is not a valid proof. All right, now there is a type of proof called proof by cases where you could enumerate all the cases, but this would be an infinite number of cases. So this would not be the correct approach, right? Especially this one particular, it's an example of the implication, right? But it does not constitute a proof, right? A proof would have to be for all AB, right? That is an even number, right? Then A or B is even, all right? So I'm going to switch over to our textbook so we can see kind of the various different approaches, and we'll go over which one is valid and invalid here. Now, here, one thing that is going to come up throughout the course is this idea of an even and an odd number, right? If a number is even, then I can always represent it like this, right? As 2 times k, where k is some integer, right? This fancy z here is an integer, right? So this value will always give you a even number, okay? So this 2k, right? Whatever k happens to be, whether k is odd or even, that factor of 2, again, makes it even, right? Again, because what makes an even number is that it has 2, that it can be divided by 2 even, or as a divisor of 2. All right, now the way numbers are ordered, the integers are ordered, it's even, odd, etc. So that means that if 2k is even, the number next to it will be odd. So any odd number can be represented like this. Okay? All right. Okay, now let's take a look here at our textbook where they present this statement for us. right? So it says suppose, again, one that I brought up, that I wrote on that virtual chalkboard here. So the question is, if A and B is an even number, then A or B is even. So which of the proofs appear to be valid proofs of this statement? Now here and again it says all this algebra is the same. All right. Now, which proofs below appear to be valid proofs of this statement? Now look at the first one, right? Now the first one does not start where we would expect it to start, right? And again, our implication, right? That first part of the if statement is our hypothesis. So we assume that that is true, and then our implication is we want to show that if that is true, that leads to A or B being even. Now, the first one says suppose A and B are odd. All right, now it takes a vastly different approach here, right? Now, it's not out of the question here, right? Because in a previous section, we've seen here, hold on. Okay, so in a previous section, we said that if we have some statement where P implies Q, right? Q implies P, right? Not always guaranteed to be true, but what is always true was the contrapositive. Not Q implies not P, right? And so if we look at the way that that statement is written, right? If A or B is even, what would the negation of this be? The negation of A or B even, right? Again, from the Morgan statement, right? The negation of an or, right, is an and statement, right, with the negation of A and B. So the negation of A or B being even is the same as saying, or the negation of that is A is odd and B is odd. All right. So here, what that brings here, all right, looking at this, this actually does look like a valid way to approach this problem, right? Because we're proving the contraposition, right? If the contraposition is true, then the implication is true, right? So again, right, they take that formulation, A is 2k plus 1, right? Odd, and they multiply it out. Do a little factoring here, right? Where factor of 2 out of these values. And here, again, 2, remember, k and m are all integers. So adding integers and multiplying integers results in another integer, right? So 2 times some integer plus 1 is odd, right? So we see here they took the approach of negating the conclusion and proving the negation of the hypothesis. Well, we've seen from a previous section that is a valid approach. Okay. All right, now let's look at 2. Assume that A or B is even. Now again here, right, as we can see here, they start with the conclusion. Right, very common mistake here that I see with some of this when I look teaching this idea of proofs, right? We don't want to start here, right? We don't want to start with our assumption being the conclusion of our statement. Okay? Again, not to say that it's not true, right? But it does not prove our implication, right? What we want to prove is that if we start with A and B being even, right? Then we can conclude A or B is odd. So we could see here that the algebra itself is correct, right? But it is not a proper approach for this type of problem. All right. Okay, so here, now this one is a different approach here. It says suppose that A and B is even, but A and B are both odd. Okay, so here they assume that the initial part is true, but then uh, they go with the conclusion being false. Okay, now a slightly different approach here, right, where we negate it, right, and here we can conclude here, right. If that's the case, then it is odd, which looking at the algebra here, turns out to be impossible, right? So what does that prove about A and B being even if A and B are both odd? that can't be true, right? So this appears to be valid here. All right, so now our fourth one, let AB be an even number. Say AB equals to 2n, and A be any odd number, right? Again, here, right, our assumptions, right? Okay, so if A is odd, okay, which again not is, we could say, okay, that's good here. That seems fine, right? So if A is odd, right, then we conclude if that happens to the case, and therefore B is even. Okay, so a slightly different approach. Now, here, notice there are, we can see there's more than one way to try to prove this. Which way to choose? Again, in some cases, you'll just be asked to do a particular way. In some case, I'll be asked you to, it'll just be up to you to decide which one is the best approach here.